this question's a little bit more involved. And so what we need to do in here is we're told we've got a spherical hydrogen balloon. And we're told the diameter of this balloon, and we're told it's used to carry some equipment. And what we have to do is we have to find the maximum altitude that it will reach if the total mass of the balloon and all the instruments is 200 grams. We're told the instruments have negligible volume, so in other words, we're only considering the volume of the balloon, and the volume of the balloon remains unchanged with altitude. And we're also given some conditions of the atmosphere, so we're told the density and temperature at sea level, the gas constant, and also the constant lapse rate. So if you think what's going to happen is we're going to release this balloon, and it will initially have a higher buoyant force than due to the weight of gravity, so it will shoot up in the air. But eventually, as it climbs and climbs and climbs, the buoyancy force will decrease and decrease until it reaches a point where the buoyancy force is equal to the weight, and that's where it will stop, and that will be its maximum altitude. So working from that assumption, when we get to that point, the buoyancy force, as I say, will be equal to the weight, and the weight is equal to the mass times the force due to gravity. We're told the mass of the balloon and the instruments, and it's 200 grams. So the buoyancy force that we need to balance that is 1.96 newtons. Okay. But we also know that the buoyancy force is equal to density times gravity times the volume, remembering that this is the density of the fluid, and that equals 1.96. So you'd think that would kind of be it, but how do we find this density? That's the issue. That's what we're going to try and find. So this is from the previous slide. We know if we can find the volume, then we can find the density. And the volume of a sphere is given by this relationship. So it's 4 over 3 pi r cubed. So by putting in the values we got from the question, we can work out the volume of the balloon. Remember, we're told that the volume of the instruments is negligible, and that's 0.322 meters cubed. So now we can work out the density, the atmosphere that in which the balances would be, the forces would be balanced. So if we put the volume into here and work that out, we get a density of 0.62 kilograms per meter cubed. So in other words, we got the density. We can we know what the density needs to be for these forces to balance. So we just need to work out what altitude that is at. So if you remember back to the lecture on the atmosphere, we know that for a constant lapse rate layer, the density ratio is given by this relationship. Okay, so if you're not sure where this comes from, go back and have a look at the lecture on the atmosphere. And just to remind you that all the subscript zeros in here are the conditions at the base of the layer. So it's the density at the base of the layer, the temperature, and the altitude. So we can just put our figures into values into here. We know the density that of the altitude that we want. Okay, so we've worked out on the previous slide, that's 0.62. We were told the density at sea level. We know the temperature, so also remember we need to convert that from degrees Celsius into Kelvin. The lapse rate, remember we've got to have it in the right units, that's kelvins per meter. The altitude is at sea level is 0. So now we have one equation, one unknown, and we can rearrange that for z, and if you do, we end up with an answer of 6,550 meters.